I Ratnamala, Assistant Professor of Physics, V.V. Vanni Perumal College for Women, Virudhunagar. Today, in the fast-growing world, there is an energy crisis occurs, mainly because of reasons like utilization of fossil fuels, increase in population, wastage of energy, etc. So, in order to overcome these problems, we are in need of some kinds of energy storage devices like sensors, batteries, solar energy gadgets, etc. So, in order to make these devices, we are in need of semiconducting material. So, semiconductor make a vital role in order to make these devices. In this module, let me explain the semiconductor PN junction diode, forward biasing, reverse biasing and its VI characteristics curves. Let us begin. PN junction diode. It is nothing but junction made up of P-type crystals in contact with N-type crystals. The surface of contact of both P and N-type crystals leads to the junctions. Normally, the PN junction is the basics for all kinds of diodes, certain transistors, solar cells and any kind of devices. So, it is a device that conducts current in only one direction. So, it holds the future that allows the diode, transistor and any kind of devices to work. Here we see that the junction is formed by P-type crystal in contact with N-type crystals. Here is the schematic of PN junction diode. The surface of contact of these two P and N-type crystal make the junction. Next comes the formation of PN junction and depletion layer. All we note that in the P-type region, holes are the majority carriers. Positive holes are the majority carriers. Whereas in the N side, electrons, negative electrons are the majority carriers. Even though in the P side or P region, positive holes are present, but a small amount of minority carriers, that is electrons, are present in the P region. Similarly, in the N-type side or N region, the minority carriers, holes are present. Minority carriers, holes are present. So, this depletion region is formed. In the P side region, the majority carriers drift towards from left to right, whereas the electrons diffuse from right to left. So, at that time, holes leaving and the electrons entering into the N side make it positive. Similarly, electrons leaving and holes entering into the N region make it positive. So, there is a net positive charge on N side. Similarly, there is a net negative charge on P side. So, here the electric field is developed across the junction. So, in the equilibrium condition, there will be the electric field. This electric field is large enough to drift the electrons from N side to P side. But here, only this electric field is applicable to move the minority charge carriers, not the majority charge carriers. And the depletion region, normally the width of the depletion region is in the order of 10 power minus 6 meter, whereas the potential developed across this region is referred to as potential barrier. Next comes forward unbiasing condition. Here we see that in the P side, holes are the majority carriers and in the N side, electrons are the majority carriers. Here the depletion width in the unbiased condition is represented here. So, under no voltage or unbiased condition, the diode does not allow current to flow through them. So, here no biasing takes place. This type of condition is referred to as unbiasing condition. If the external forward voltage is applied on these PN junctions is increased from 0 to 0.1 volt, the depletion region only slightly decreases. So, therefore, not much amount of current flows through the device. Next comes forward biasing. Suppose the positive terminal of the P region, positive terminal of the battery is connected to the P-type region, while the negative terminal of the battery is connected to the N-type region. Here we see that the depletion region, the width of the depletion region becomes narrow. So, it conducts more number of free electrons and holes are generated in the PN junction diode. So, therefore, the large number of electrons and holes reduces the width of the depletion region. Here we see that. This depletion region decreases with increase in voltage. This occurs in the case of forward biasing. Next comes reverse biasing. Here, the width of the depletion region increases as compared to that of the forward biasing. Here what happens? Here more number of free electrons and holes are pulled away from the PN junctions. So only the width of the depletion region becomes increases. So this depletion region increases with respect to that of the increase in applied voltage. Next comes the action of PN junction diode. What actually does PN junction diode? It allows electric current in only one direction. So only in forward condition, and it blocks the current in opposite direction, that is during reverse bias. Next comes VI characteristics. Here is the experimental arrangement to study the VI characteristics of PN junction diode. Here is the diode, negative terminal, positive terminal, and the voltage developed across the diode is measured with the help of voltmeter. In order to measure the current in the circuit, we are having milliammeter. Here is the forward characteristics curve taking voltage along x-axis and current along y-axis. Here we see that if we increase the voltage, the current increases, but after certain times, the voltage becomes constant. Such a voltage is referred to as mean voltage of that particular diode or particular semiconducting material. Next comes the reverse characteristics. Here also taking voltage along x-axis and current along y-axis. Here if we increase the voltage, after a certain time, it breaks down at particular value. That voltage is referred to as breakdown voltage. So with the help of these characteristics curves, one can find the mean voltage as well as AC forward bias resistance. So with the help of forward biasing, here we note that taking the slope del V and del V along x-axis and del I along y-axis, for the semiconducting material like silicon, the mean voltage is normally lies in the value of 0.7 volt. So after taking slope, we get the value slope is equal to del I by del V. So R is equal to del V by del I, which is equal to 1 by slope. This is nothing but AC forward resistance. So one could calculate the AC forward resistance with the help of slope. That is, it is the inverse of slope. And next comes reverse voltage breakdown. Here, avalanche breakdown mechanism occurs. In the reverse bias is very high. So therefore, the current flows through the PN junction increases abruptly. The current flows through the reverse bias increasing abruptly, and the voltage at which the phenomena occurs is called breakdown voltage. So at this breakdown voltage, the crystal structure breaks down, and this causes large amount of current flows through the material. This particular phenomena is referred to as avalanche mechanism. So here is the diagram, shows the avalanche breakdown. Here we see that the width of the depletion region becomes very large. So when a reverse voltage is applied across the junction, the minority carrier gets sufficient amount of kinetic energy. So with the help of kinetic energy, more number of electrons are produced in these mechanisms, and it will knock out some more electrons. So this will create few more electrons and get sufficient kinetic energy with the help of that electric field, and once again it creates more number of electrons by the collisions. So due to this cumulative phenomenon, huge number of free electrons are created in this depletion layer. So therefore the entire diode will become conductive. So this type of depletion of the breakdown of the mechanism is referred to as avalanche breakdown. So here this diagram represents both forward and reverse bias characteristics of the PN junction diode. Here we know that the semiconducting material silicon, the mean voltage is normally 0.7 volt, and it is depicted here. For the semiconducting material like germanium, the mean voltage is always in the order of 0.3 volt. So this is the mean voltage for this respective semiconducting material. Whereas in the reverse bias, we can attain the reverse breakdown mechanisms, otherwise avalanche breakdown. So here it is depicted in the diagram. I hope also understood the basic details behind PN junction diode. Thank you.